Log on, tune in, find out. Another good idea from Cambridge.
Well, it's a great privilege to introduce Sir John Houghton to you. He is currently Honorary Scientist at the Hadley Centre for Climate Prediction and Research. He has had a distinguished career, and I'll just pick out one or two of the very significant posts he's had. Fairly recently he was chairman of the Scientific Assessment Group of the Intergovernmental Panel on Climate Change, the world body that has produced very significant reports on the climate, global warming and so on. He was, before that, Director General of the Meteorological Office in Britain. He's been Professor of Atmospheric Physics at Oxford. And I think, as I say, no one better qualified to open our conference for us. Thank you.
It's a great pleasure, privilege to be talking to you here tonight on this subject of global warming and what we can do about it. I'm going to start by putting global warming in the broader context of what you might call sustainability. And I want you to imagine that you're one of a party taking a space voyage to a distant planet. 6 of you are in the crew, and you're going a long way, and you're going to have to live for a long time. So how do you do that? You have to take with you a little farm, a little place where you can grow things. I call it the biosphere module. I needn't go into detail. You can imagine the problem. You have to make sure that you can grow food, make sure that you can recycle absolutely everything. You have a source of energy from the sun, otherwise you have a source of nothing. And you have to therefore recycle things and make sure that you can mend things, you have to take repair kits, and it has to be very sustainable. Now, it was in 1966 that a distinguished American economist, Kenneth Boulding, wrote an article describing spaceship Earth and explaining what a spaceship economy would be. And this was actually before the first Sputnik. People were imagining space voyages in those days. And he contrasted that with what he called the cowboy economy. And I need to explain what a cowboy economy is, because you all live in one. He talked about Spaceship Earth, which doesn't have 6 crew, but 6.5 billion crew. And if we're going to be sustainable on Earth with that many people, we have to learn to be sustainable in everything that we do. That's what we mean by sustainability. A very simple definition, working definition of sustainability is to say it's not cheating on our children, we're looking after subsequent generations. It's not cheating on our neighbours, we are loving our neighbours in distant parts of the world and looking at caring for them in the ways that we need to do that. And we're not cheating on the rest of creation. In other words, we're allowing other creatures, plants, animals, to live on Earth and coexist with us and also relate to us in all the wonderful ways that they do. So that's just trying to begin this whole process of sustainability and explain what it means. Then, but we're not sustainable. We're extremely unsustainable. I just list here, I'm not going to take any time over it, list here some of the reasons why we're unsustainable. Because of poverty, because people don't have clean water, because people don't have energy, we're losing habitat at a great species at a great rate, because of unsustainable use of land and loss of forests and soil, all driven by population growth, by overconsumption, by unsustainable trade, and finally by climate change. So let me move on to climate change. The underlying physics of global warming has been known for about 200 years, called the greenhouse effect. Radiation comes in from the sun, warms the Earth's surface, comes through the atmosphere without any, in the absence of clouds, largely unimpeded. That energy coming in is balanced by energy going out in the infrared part of the spectrum from the Earth's surface, thermal energy, heat energy, whatever you care to call it. Some of that gets out to space, but a large proportion of it is absorbed by greenhouse gases in the atmosphere on the way out. And because that radiation is absorbed, that's just like a blanket over the Earth's surface, just like a blanket in bed. It's warm at the bottom of the blanket, underneath the blanket, it's cold on top of the blanket, and therefore because of those greenhouse gases, the Earth's surface is warmer than it would otherwise be. Now that is a process that gives us the climate, the rather nice climate, suitable for humans, which has been around, of course, on Earth for a long time. Because of the natural gases in the atmosphere, water vapour, carbon dioxide, and other greenhouse gases which are there for natural reasons. In fact, if those gases weren't there, the Earth's surface would be very cold, in fact would be covered by ice. And I guess this lecture tonight would be in an igloo rather than in this nice room in Cambridge. So we need the greenhouse effect to give us the sort of climate we've got. But then some of these gases are being increased in their concentration in the atmosphere because we're emitting large quantities of them, and in particular carbon dioxide. We emit something like 7 billion tonnes a year of carbon as carbon dioxide into the atmosphere from burning coal and oil and gas. Methane is also increasing because of things that are linked to humans. Lots of cattle on Earth emit methane from both ends. Sheep do the same thing. Paddy fields, rice paddy fields, emit methane and so on. So things that are linked to human activities are also increasing methane by quite a big amount. And you can see that over the last 200 years, these gases have gone up in a way that they've never changed before for a long time. The carbon cycle has kept carbon dioxide at a very uniform level in the atmosphere for thousands of years, until all of a sudden it's shooting up to the ceiling. Now it was at 280 parts per million with the Industrial Revolution. It's now about 380 parts per million, and it will head up to 500, 600, 700 parts per million by the end of the century, unless we do something about it. Now that's resulting in temperature changes. But this shows you the last 160,000 years, just to show you what's happened over that period, the last ice age, to put the present climate in context. You will see there the temperature in the polar regions as it's varied over this period of the last ice age, which finished about 20,000 years ago. How do we know that? We can measure in ice cores, drill ice cores from under the ice in Greenland or Antarctica. We can take kilometres of ice cores, because the ice is kilometres thick, and go back in time, all the way back to something like 600, 700, 800,000 years now. This is just 160,000 years, the last ice age. The last warm period was about 120,000 years ago. And that, of course, was a big change in climate. And you may say, well, people talk about big changes in climate in the past. If we've had big changes before, why are we worried about big changes now? We understand what triggers ice ages. It's the variations in the Earth's orbit around the Sun. The ellipticity of the orbit varies. The tilt of the Earth's axis varies. The time of which the Earth is closest to the Sun varies. with periods of 220,000 and 40,000 and about 100,000 years respectively. And because of that, the amount of sunshine, particularly in the summer over the polar regions, over the North Polar regions, changes by 10–15% from time to time, with periods that are around that amount. And that's what makes the ice grow or makes the ice melt, as that radiation changes, and hence the ice age. Now the red line is the temperature over this period as measured from the ratio of the isotopes of oxygen in the ice, telling you with the temperature at which the ice is laid down. The green line is carbon dioxide as measured from bubbles of air trapped in the ice at different periods, and therefore you can measure the carbon dioxide, and they track each other very well. Don't jump to the conclusion that that's a proof that carbon dioxide changes actually change the temperature, although that is true. But it does show that things that change, the factors that influence the temperature also influence the carbon dioxide, and that's certainly true. And we can't model the climates of these periods unless we assume that also the carbon dioxide changes the climate, changes the temperature. But look at the right-hand side. Look at that green line that's heading for the ceiling again. A very rapid change indeed to levels of carbon dioxide concentration that we haven't seen for millions of years. So all of a sudden, humans are changing this critical gas at a rate which is outside anything that's ever happened, at a rate that's never happened before, at least for millions of years or so, for natural reasons. So that's the growth of carbon dioxide. Now, this is a temperature of the 20th century. And you will see there a substantial change of temperature. It's about 3/4 of a degree over the whole century. And I'll just talk about the last bit, which is the bit from 1970 onwards, which scientists are really almost certain that is due very largely to the growth of greenhouse gases. It's an accelerating rate of temperature rise. And you may say, of course, well, what about the temperature rise from 1900 to 1940? We believe that was due to the absence of volcanoes and variations in the sun is our best explanation for what happened over that period. But the latter period of last century fits very well with what we know about the increase in greenhouse gases and what they would do. I could say more about that, but I won't. But I'll just show you this, because there are some people around at the moment who are saying, you see the temperatures stopped rising. If you look at the temperature since the year 2000 to the present, the temperature it looks as if it might have steadied off. So people say, you scientists, you're just imagining all this growth of temperature. The temperature is steady. Well, there's enormous variation from year to year here. These are averages over the year and the global average temperature. Average over each year for all this period from 1850. If you take the 7 years of this century and compare them with the last 7 years of the 20th century, there's a rise of 0.1 degrees, which is exactly the right sort of trend, which matches the trend from 1970. And there are reasons why the temperature is not rising so rapidly just at the moment, because of the behaviour of the El Nino. If you look at 1998, which is the warmest year on record so far, that was an exceptional El Nino year. And the El Nino is a big change in the temperature in the Pacific Ocean and so on. And so there are reasons for these variations, which we understand to a reasonable degree, and we expect that rise to continue because of greenhouse gas warming. Well, there's the 20th century temperature rise you've just seen on the left-hand side of that diagram. And now we project to what's going to happen this century. How do we project? Well, we use climate models. These are computer models of the whole climate system, the atmosphere, the ocean, the ice and the land, putting all the interactions between those various parts of the system, all the dynamics of the circulations of the atmosphere and the ocean, and actually run the model for a few hundred years to discover what is going to happen this century as we change the amount of carbon dioxide. Very sophisticated modelling. Your weather forecast every day comes to you courtesy of an elaborate computer model of the same kind, except that it doesn't have to include the oceans and the ice, it just includes the atmosphere. And our best estimates are that the temperature this century is going to change not just by a few tenths of a degree, but by between 2 and 6 degrees. That's a big change. It may not sound very much to you, because the temperature in this room has probably changed by a couple of degrees since we all came into it. So you say, what's a couple of degrees? I'd like 2 degrees on a cold day. But this is the global average. If you remember the Ice Age diagram I showed you a few minutes ago, and you take the difference in global average temperature between the middle of the Ice Age and the warm periods in between, it's only 5 or 6 degrees. So 2 or 3 degrees, which would be an average warmth for this century, with business as usual as far as putting gases into the atmosphere is concerned, that's about half an ice age this century in climate change terms. That's enormous. That's a rate of change which is that's occurring in 100 years. So it's a rate of change faster than the Earth has experienced for thousands of years. And it's that rate of change which we're going to find very hard to adapt to. And not just humans finding it hard to adapt to, but ecosystems also are going to find that rate of change very hard to adapt to. So that's the basic science. But talking about global average temperature doesn't really tell you very much. Well, what's going to happen? What's the impact going to be, you say? And of course, the climate change across the world will not be uniform, because we have a very non-uniform surface on the Earth, and it's going to be very different in different places. Let me just mention 3 things: intense heat waves, sea level rise, and a more intense hydrological cycle. In 2003 in Europe, there was a very unusual heat wave. Unprecedented heat wave. So much so that it was right outside the limits of what we imagine to be natural variability. Central Switzerland, the average temperature for June, July and August, 3-month average, from the year 1864 until 2002. All the blue lines showing you one of those years on a temperature scale, which you see at the bottom there. Average temperature over the whole period of about 17 degrees Celsius, ranging from 13 or 15 or so to 20. 2003, 2.5 degrees, 5 standard deviations away from the average temperature. Now, that's an enormous difference. If you were to do a return period analysis on that temperature in the summer against what you know about what's happened over 150 years or so, you would come up with thousands of years, if not 1 million years. Just outside, completely outside what we know of natural availability. So scientists say, who studied it, well, most of the risk of that event came from the increase of greenhouse gases. It has to. And indeed, by the year 2050 or so, we expect that to be an average summer. By 2100, it will be a cool summer. That's the sort of rate of change of temperature we're talking about. Now, in that heat wave, at least 20,000 people died prematurely. A better number is probably about 35,000, but I like to quote very conservative figures. So that when in that year I started to talk about climate change being a weapon of mass destruction, and people said I'd gone off my head because I just was hyping it up in my old age or something. That wasn't the reason at all. The reason is there is firm evidence that because of climate change, people are getting killed off. There was in that year also, incidentally, an intense heat wave in India and in other places too. But thousands of people died in India because in Andhra Pradesh in India they had 27 consecutive days of temperatures above 46 Celsius. They always get temperatures of 46, 47 for 2 or 3 days in May each year. But in May 2003 they had 27 consecutive days and thousands of people died. Sea level rise. Now, as the oceans warm, they expand. So the sea level will rise as global warming takes effect. And the rate of rise of sea level on average is about half a day, due to the ocean warming, is around half a metre a century. And this half metre a century will go on for a long time, because first of all you warm the top 100 metres, then the next 100 metres and so on, all the way down to the bottom of the ocean. So and this is going to continue for centuries, whatever we do. So we're committed already to about half a metre a century of sea level rise for a long period. Now, half a metre may not sound a great deal, but if you just go a bit east of here to the coast of East Anglia, the coastline will look very different in 100 or 200 years' time because of the sea level rise. And it's not just the oceans warming that matter, the glaciers are melting also at a significant rate. And there is question about how much the ice caps will melt in Greenland and Antarctica. Two things are happening on those ice caps. First of all, they're getting more snowfall in the middle because the temperature is slightly warmer, so they get more snowfall accumulating in the middle. That's adding to the amount of ice. Around the edges they're ablating because the temperature is increasing, and you've all seen pictures of ice falling off Greenland, looking seemingly at a great rate. And it's very hard to estimate just how fast that will melt and how much that will increase this rate of sea level rise. So we don't really know the answer to that at the moment, but it's almost certain to be 10, 20, 30 centimetres this century of additional sea level rise because of melting of Arctic ice. It may be more. In East Anglia, they will have to spend billions on dealing with the coastline. Lots of other parts of the coasts of the UK will be affected also. The Thames barrier will have to be rebuilt and so on. But go to Manchester. There's the 1, 2, 3 and 5 metre contours. There are 10 million people who live below the 1 metre contour. By 2050 there will be 20 million people living below the 1 metre contour. They're not going to be able to live there anymore. You can't conceivably build a sea wall around the delta region of Bangladesh. So where do those people go? 25 million people in southern China similarly affected. Lots of islands in the Indian and Pacific Oceans won't be inhabitable. People will have to move. I met a man from Papua New Guinea not long ago who said that there was an island very close to Papua New Guinea where they've been farming for years in the edge of the island. It's a very low-lying island, and but they can't farm there anymore because the sea level rise has just come up that little bit that brings in salt and water too often for there to be grow food at all on an island. There are 200 people who live on the island. They wrote to the United Nations a few years ago saying, please, will you find us another home? And they've not had a reply. Now, there are lots of people who will be in that position in due course. And all around the world, the Nile Delta, other delta regions, significant parts of Florida, and so on. problems of sea level rise will be very large. The more intense hydrological cycle. In a warmer world, there'll be more water evaporating from the oceans, more water vapour in the atmosphere, and that means more precipitation on average, more rainfall on average. And we're seeing that happen. And water is a very important resource, and the distribution of water around the world will change quite substantially. I show that just because it's the Nile flowing through the Sudan. It's a shared river. And a lot of rivers in the world are shared between nations. And there's going to be a lot of conflict between nations over water in due course. There's been conflict recently in Africa because of the droughts they've had, fights over water. We're going to see wars over water. Lots of UN people have been saying that for a long time. The red region there, incidentally, is a picture from space. That's irrigated land, irrigated from the Nile. You're growing crops in the desert. Very good thing to do. But how long can we carry on using water in that way? Now, this extra water vapour in the atmosphere not only increases the rainfall on average, but when water condenses to form clouds, it releases a lot of latent heat. Now, that latent heat is the largest single source of energy for the atmosphere's circulation. So there's more energy in the circulation, and what that means in simple terms is on average you're going to get more intense rainstorms. The water is going to tend to come down in bigger drops because of the more intense circulation. It also means that some of the air will be drier because it goes higher and gets colder, and so we're going to tend to get some arid regions will get more arid, and you're going to get more droughts. So droughts and floods are likely to occur more frequently and with more intensity. Now, this just illustrates some of the changes of precipitation which are likely to occur towards the end of this century. The blue regions are going to get wetter, the red regions are going to get drier. Roughly 20–30% each way from the normal. That's an enormous change in average rainfall. Just look at the Mediterranean region. It's pretty dry at the moment in the summer. This is the summer months, incidentally, or the northern hemisphere summer months. The Mediterranean will get will have much drier summers on average. That's very serious news for our friends in that part of the world. I happen to live in Wales, and I often say to the Welsh people who are interested in tourism, you must get ready for all this influx of tourists, because they're not going to want to go to the Mediterranean anymore, so they'll probably come to Wales. Why don't you get ready for it? These big changes in water amounts are going to, as I've already said, mean big changes in the climate extremes, the extremes of floods and of droughts. Now, floods and droughts are the most damaging of the world's disasters on average that we know. They cause more misery, more deaths, more economic loss than any other disasters we know. And that just gives you some numbers of the people affected in recent decades. Now, so more floods and more droughts is very bad news for people, especially in subtropical countries where floods and droughts are frequent and intense. It's also bad news, incidentally, particularly floods in our own country, because we're getting more floods at the moment, and we're going to get more floods in the future. We're going to also find much drier summers in some parts of our own country, never mind what happens elsewhere. But drought is a very serious matter for people in many subtropical countries. Africa's been having severe droughts, Australia's been having very severe droughts, we've had droughts in Asia, we've had droughts elsewhere in the world. And the most frightening statistic I know about the likely impact of climate change concerns the impact of extreme droughts this century. Extreme drought is defined using what's called the polar index of drought in rather specific ways. You have extreme droughts, you have moderate droughts. Severe droughts and moderate droughts. Let's take the most extreme droughts. And some work at the Hadley Centre recently, using modelling, has studied droughts rather carefully. They've studied the incidence of droughts over the last 20 years to make sure that we're trying to matching quite well what has actually occurred. And then they've run the models out to 2100. If you take the usable land area of the world, that's the land area minus the deserts and so on, at any one time at the moment, something like 2% of that area is under extreme drought. 20 years ago it was 1%. By 2050 it's likely to be 10 or 12%. By 2100, particularly if we do nothing about it, it's likely to be 30%. Now imagine the impact of that on many marginal countries which have marginal agriculture now for some periods of the year. Impacts of droughts which will be much longer than they were before because they're more often. Droughts, so instead of lasting a year, might last 3 years or 4 years. Now people in developing countries can survive for a year without rain because they get food through food aid, they get seeds for the next season, and providing there is a next season, they can go back and get on with it. But if the drought lasts for 2-3 years, what are they going to do? Where are they going to go? Another major problem of people wanting to move from where they are in order to survive. So, impacts of climate change, I've tried to summarise them for you there. Just look at the bottom two lines. Many millions of environmental refugees, the loss of millions of species in the ecosystems, which is a major problem for ecosystems to survive. So how sure are we about this sort of story? I was privileged to be chairman or co-chairman of the scientific working group at scientific assessments of the IPCC from 1988 to 2002. I went through 3 cycles of the reports, which came out in 1990, 1995, 2001. I was not responsible for the one that came out in 2007. We involved all the scientists in the world we could find. Hundreds of scientists got involved in the process, either as authors or as reviewers. We went out for reviewing processes to the scientists twice, and then to government scientists as a further end of the reviews. And these volumes, this is the 2007 scientific volume, 1,000 pages long, A4 size format. And if you have and there are 3 volumes like that, because there's also one on impacts and one on mitigation or the economics of climate change, which have come out each year, each 5 years or so since 1990. And there's the website. If you have the patience, the paper, and the ink, the time, you can download them all. And do have a look at some of them, because it'll give you a real impression as to what was done in that process. There's been much rubbish talked about the IPCC by people who want to spread misinformation. There's a lot of misinformation on websites describing the work of the IPCC as if we were environmental lobbyists, greenies, people who had no honesty, and so on. And that has been a difficult thing to take, even though the fact that it was going on actually made us more accurate and more honest, I think. But just look at what I've written at the bottom there. In June 2005, the Academies of Science, that's the top scientific bodies in this country, it's the Royal Society, in other bodies it's the Academy of Science, in the top 11 countries of the world, clubbed together to write a statement on climate change for the G8 meeting, which is that year in Scotland, saying, please G8, please take notice of what the scientists are telling you about climate change, because it needs urgent action on your part. And incidentally, look at the IPCC reports if you want to know more. It was an absolute commendation of the work of the IPCC. You could not have a stronger endorsement by the world scientific community than that, because those academies hardly ever get together about anything. And for them to get together at all was remarkable. That, incidentally, they've got together again, but it's included now South Africa and Mexico, as well as India, China and Brazil. And they've written to the G8 conference in Japan, which is going on in the next few weeks, in very similar terms, saying, please G8, please get on with it, because we've got to do that. So what can we do about it? Let me take you to the 1992 Earth Summit in Rio, where the Climate Convention was signed by all countries in the world. It was signed by President Bush I for the United States. It was ratified unanimously by the US Senate a few months later. And the key statement in that document is the objective, which is to stabilise greenhouse gas concentrations at a level which has been chosen so that it prevents anthropogenic interference with the climate system, or dangerous anthropogenic interference with the climate system. It allows ecosystems to adapt naturally. It ensures that food production is not threatened. It enables economic development to proceed in a sustainable manner. In other words, we've got to stabilise the climate. We've got to stop it changing, or stop it growing. But we mustn't do it too fast. We mustn't stop doing everything in order to do that, because we still have to live and we still have to eat food and so on, and we must look after our systems in order to do that. Is that achievable? This was in my set of slides for a talk I gave the other day to a conference on unsustainability, the roots of unsustainability. So I say this provides a working definition of a sustainable climate. Is it achievable? Various stabilisation targets are being talked about at the moment. The one that's really being pushed by countries and by others is that of maximum of 2 degrees change in temperature. Remember the temperature curves I showed you earlier on that went 2, 3, 4, 5 degrees, which means about 450 parts per million in terms of carbon dioxide concentration. It's at the moment about 380. It implies that carbon dioxide emissions will have to stop growing, peak around 2015, or certainly by 2020, and cut by 50% or so by 2050. So that's sort of curve we're looking at. The cost of doing that has been worked out by various people. Nicholas Stern wrote a volume on the economics of climate change, which was set up by the UK government. And he comes up with a number of about certainly less than 5% of world GNP by 2050. In other words, that's 2 years economic growth between now and 2050. We'd have to go into actually doing that. So the cost is not large. It's almost in the noise level. So it's achievable from the cost point of view. And what does it mean in real terms? That's the curve. At the moment we're emitting 7 tons of carbon as carbon dioxide, which means about 27 billion tons of carbon dioxide when you add the weight of the oxygen as well as the carbon, which has to peak around by 2015 and come down to 450 parts per million by a factor of 450 parts per million as a stabilisation level. Or 23 gigatons of emissions by 2030. Business as usual is the top line there. And this is a diagram that comes from the International Energy Agency. That's the body that links together the energy industries of the world and the energy ministers from all the OECD governments of the world. And they are the top industry body, top energy body in the world. They're now addressing this question, how can we do it? And they show the means by which it could be done. And they talk about a cost over this period of $22 trillion, which is 1 or 2% of world GDP. It's not a lot of money. What are the main major changes they're talking about? They're talking about increasing in energy efficiency, halving the energy use in buildings, carbon capture and storage, I'll say something about that in a minute, in all coal-fired power stations by 2030, carbon-free electricity by 2030, and a progression in car technology that weans the cars off oil. I'll move on and say a bit more about how we change the energy in a minute, but just let me show you this. Supposing you're in an international meeting of diplomats who are trying to decide how we share carbon dioxide emissions between the nations. And the first picture you're shown is this one. This shows the per capita emissions, the emissions per person in different countries or groups of countries in the world. On the left-hand side, you've got the USA and Canada with an emission per head per year of something like 25 tons. Europe, we're around something like 10 tons. China is something like 5 tons, and India is about 2.5 tons. There's an enormous disparity between the rich countries and the poorer countries on this diagram. What is plotted along the bottom is population, so the area of each of these curves showing is proportional to the total amount emitted by those countries. So China, the green bit in the middle, East Asia it's called, has now just surpassed what's the blue line on the left, which is the USA and Canada, because of course they have a much bigger population. That raises an enormous problem because the average over the what's called the Annex 1 countries, the rich countries, is around 16 tons per capita. The average for the poor countries is about 4. So there's a disparity of 4 to 1 between the rich countries and the poor countries. So how are we going to share it out? And that creates an enormous moral imperative to the rich world in particular. We've grown rich because we burnt coal and oil and gas. We burnt fossil fuels and we've grown very wealthy. We didn't realise the damage we were causing, especially to poorer countries, because they suffer more than we will. Which means that we have to reduce what we're doing in the rich world as fast as we conceivably can. We've also got to learn to help poorer countries to develop sustainably with our wealth and our skills. So there's a very big moral imperative implied by that. Having thrown that moral imperative at you, I will come back to it in a bit. But let me first of all say what sort of action we can take in order to reduce emissions of carbon dioxide. I've already talked about those things. More efficient energy generation and use, sequestering carbon dioxide underground, and energy generation by renewable means. And energy efficiency, we've got a third of our emissions goes into buildings, a third into transport, and a third into industry approximately. Let's still talk about buildings. There's a map of Aberdeen. A picture of Aberdeen taken from the air in the infrared. The red buildings there are warm, the blue buildings are cold. The red buildings are badly insulated and leaking heat. The blue buildings are much better insulated and are more energy efficient. Some of the buildings near the centre of the city old buildings and not very well insulated. But look on the outskirts, some of the new estates, they're lead buildings. We have no right whatever in this day and age to be putting up lead buildings. We're still putting up lead buildings, which leaves a lot of energy. You go to Scandinavian countries, they would all be blue buildings. We're not very good at it. If you go to continental Europe, you'll find a lot of energy comes as combined heat and power from power stations, so that you're getting your electricity that way, but you're also getting your hot water that way. Heat your houses in the winter, because more hot water is piped out of power stations. We've got very little of that in the UK. So I'm addressing UK people here, but letting those of you who are not in the UK know how bad the UK is at it. Despite the fact that we talk a great deal, we don't do what we should do. That's another building. That's another building with an infrared picture of the Houses of Parliament, which you might find amusing. Carbon capture and storage. This is a Norwegian project at the moment. The gas comes up from the under the sea of Norway, and that gas contains 15-20% carbon dioxide. They have to take that carbon dioxide out before they can sell the gas. They would normally leak it to the atmosphere, but they have a carbon tax in Norway, which means it actually pays them to pump that carbon dioxide back into the rocks from which it came. That's what we call carbon capture and storage. Perfect, it's been working for years in Norway in this limited way. You take a coal-fired power station, you have to get hold of the carbon dioxide. There's a separate stream. You've then got to pump it down into old oil and gas wells or rocks that are suitable for that purpose. And there are rocks that are suitable for that purpose. Carbon dioxide is liquid as it's at high pressures, so it can stay in those rocks, providing they're capped with appropriate strata. The Chinese are building 2 gigawatts of coal-fired power stations every week. 2 dig-up power stations every week at the moment from coal. They have lots of cheap coal. We have to try to make sure that before very long, all those power stations have carbon capture and storage. And the European Union is working with China to get a demonstration project of that kind, which is good news. But we have to get on with it. And everybody in the energy business believes that we have to get on with this as fast as we can. It needs some research, it needs some checking, we need to make sure that we do it well, but it's something we should be getting on with very fast. Now, I just want to talk a bit about energy strategy for a minute, because there are lots of people in the world, you talk to about energy, we say, how are we going to solve this problem? Oh, they say it's just technology. The answer is technology, technology, technology. Or they say the market will provide. We just leave it to the market. I've heard senior people, particularly in the United States, say, no, the market will sort it out. We don't have to sort it out, the market will do it. So I'll show you a picture of a boat, because I like going out in boats. I live near the sea. Supposing the engine on the boat is technology, and the propeller is the market. Technology drives the market. Supposing that's all that you have, where does the boat go? It goes anywhere. It could be an absolute disaster. You need somebody who has a rudder and is steering the boat so that it doesn't go on the rocks. Technology in the market are marvellous tools, but they're very poor masters. And we are intelligent human beings, and we have more about us than to leave our future, and such an important part of our future, to tools, rather than masters. I assume that those are masters, rather than tools. So what are the sort of things we should be addressing? There's a list of components of the strategy, and I'll just talk about 1 or 2 of those things. Look at the third one, is the economy must be subservient to the environment. because the environment's all wrong, the economics won't work. Economists don't like it that way around. But look at this quotation from Gordon Brown. He said environmental issues have traditionally been separate from the economy, but that can no longer be the case, because you can't do your economics without getting the environment right. I wish he would actually do what he says. And lots of economists, of course, say this. We've got to, they call the environment an externality, and we have to internalise that and bring the costs of it within the system. But politicians are very slow at doing this. The second of those strategies is you're getting potential technologies to the starting gate. You can't leave that to the market, because the market won't do it. You have to provide investment, and governments have to work with industry to provide investments. An example of a technology in the UK, which is, I believe, going to be very important, is tidal energy. We have some of the biggest tides in the world. We could get something like 20% of our total electricity from tides and from wave energy, and we should be doing it. There's a tidal, a windmill underwater, if you like. And we have some strong tides, as any of you, if you went sailing around the coast, you would know that very well. The third point is that we need to address what energy means to people. The big problem in China, that the Chinese government's very worried about at the moment, is that people are rushing from the rural areas to the cities. And they're talking of cities possibly of 50 million people per city by 2030, which is frightening in the extreme. They want to keep people in the rural areas. How do you do that? Well, the people in the rural areas want to be able to light their homes and have commercial energy and also create local industries. So how do you do that? You can do that by providing them with a local source of energy. So how do you provide local sources of energy? There's lots of energy in waste and biomass. It's been estimated, this again is IEA numbers, that if you just took the waste from agriculture and forestry and turned that into energy, you will get 10% of the world's total energy needs. And you can have local energy rather than central big nuclear power stations or big whatever it is power stations. You don't need those, you can get it locally because you can use sources of local biomass, either crops that are grown particularly for that purpose, or you can grow crops for biofuels locally too, so that you can get biofuels to run your transport and things of that kind. The potential in biomass is very large. If you're going to burn biomass to put into a power station, what sort of things you can grow? You can grow things like willow, which grows very fast, or you can use things like switchgrass, or elephant grass as it's called, which grows on poorer land. You don't have to feed it with fertilizers, it doesn't need a lot of water, and it's a much better sort of possible source. I happen to be a trustee of something called the Shell Foundation, the Shell oil company, has set up a charity to try to provide some of the poor people in the world, the poorest people, with sustainable energy. They put a lot of money, it's not a lot of money for Shell, but they put quite a lot of money into the foundation. And we're trying to set up projects in different parts of the world. And just to illustrate this, we have in China, they have enormous acres and acres of rice straw. There's a project I saw in China which was generating biogas from rice straw in a gasifier on a village scale, feeding the homes with gas to cook by. Extra energy, extra gas that was provided was burnt to develop electricity for the local energy grid. The ash from the gasifier went sold back to the farmers for fertilizer, and there are 1 million villages in China that could do the same thing. Unfortunately, the project has not gone well because the people who were doing it didn't know enough about how to run projects, but the potential is there for doing a great deal. In India, they have these large communal toilets. You can get energy from the sewage, and you can light cities or parts of cities that way. In the Philippines, there are mountains of coconut shell. Again, you can use these to generate energy, and so on and so on. Lots of potential for biogas projects. Another local source. You can take quite a small area as PV solar cells, and you can provide all of the necessities of life from 1-2 square meters of solar cells in a sunny country. We should be spreading lots of these around the world, many more than we're doing at the moment. There needs to be investment, the price needs to come down for economies of scale, and there needs to be much more push in the world for providing what are called solar home systems. In fact, in Bangladesh, the Grameen financial people have a target now for over 1 million of these and 1 million biogas systems in place in Bangladesh by 2015. Now, Africa needs them, and China, everywhere needs them, and we should be working on projects of that kind. But what I've been saying, I said it earlier when talking about the moral imperative, is that we have to learn in the rich countries to share some of our wealth and our skills with the poorer world. And are we good at sharing? And I'm talking particularly to my friends from the UK or from America or from other developed countries or from Europe. Yes, we are good in our families at sharing. We're good in our communities. We're good in our national social programs. We have all these ways of helping disadvantaged people. Are we good at sharing internationally? The answer is no. Because if you add aid and trade together, the flow of money in the world is going from the poor to the rich. And that is absolutely obscene. That's something we should not allow to happen. And we have to learn to share on a much more realistic scale. I happen to live in West Wales. That's at Aberystwyth University on the Welsh coast. They have a place called the Institute of Grasslands and Environmental Research. It's a world-famous institution. They're doing lots of research there on biosystems. That was a photograph taken last week, illustrating work amongst the sharing of work amongst all the countries of the world. There's a man from Europe on the left, there's a Pakistani, there's somebody from India, there's somebody from Taiwan, I think, and somebody from Bolivia. So there's your international operation, and behind them is a biogas hydrogen system of a fairly compact kind, which is just the sort of thing that's required on a village scale in our own country and in other countries too. So the potential, that's showing the sort of thing that we should be doing to try to get together as a world to develop things of this kind. Sometimes people say, sometimes countries say, I'm just one little person in this big world with 6.5 billion people, what can I do? I've heard people in the middle of our government say, we're only 2% of the world's problem, why should we bother? And they say that seriously. It's just terrible. You know, every person interested in the environment should have a t-shirt with that sentence on it. That's a quotation from a British parliamentarian of 200 or 300 years ago, Edmund Burke, who has lots of very good quotes to his name, quite an orator. He said, nobody made a greater mistake than he who did nothing because he could do so little. People often say to me, you know, you're wasting your time, Houghton, because the world's politicians will never agree. It will never work. So why don't we stop and do something else? Why don't I stop and do something else? And I say, well, I'm optimistic for 3 reasons. And the first is I've had this privilege of working with the world scientific community. I've seen hundreds of scientists from many countries in the world, different ideologies, different backgrounds, different personal agendas, all getting together under the discipline of science, a very honest discipline, and accepting the responsibility of explaining to the world what we believe we know quite well, and also explaining what we're very unsure about in the work of the IPCC. And that's been a wonderful experience to get this consensus amongst these very large numbers of scientists, including most of the leading climate scientists in the world. Then I know the necessary technology is there to do it. In principle, it has to be worked on, it has to be developed. A great deal of effort has to go into it. $22 trillion has to be spent on it, but it's there to do. And you may say, well, why bring God into it when I talk about God's commitment to His creation? Well, I put God there because I believe as human beings, we're not just here to be economic pawns. We're not just here to be greedy and grab all the money we can, or talk about economic growth. We desperately need moral and spiritual goals to go for in order to be fulfilled as human beings. I just put it to you in that way. And therefore I believe that there is a real future for the climate change business, because if people really got together over something like this, the world would come together in a cooperative way, in ways that it seems unable to get together for other reasons. So, trying to present to you caring for the earth as a scientific and a moral and a spiritual challenge. Now, Sir Christopher Tickell was a British diplomat who was at the United Nations for a long time. In the 1970s, he was not a scientist, but he became very interested, one of the early people to get interested in the climate change problem. He wrote a book on climate from an international point of view, and how climate work might be done internationally and so on. He was a real visionary in the subject. In a broadcast, he's not a particularly religious person, he called himself a humanist, I think. But he said, mostly we know what to do, but we lack the will to do it. In other words, it's a moral and spiritual problem. So if we talk about this unsustainable climate that we've got, and the fact that we're not doing what we should about it, this is a slide I prepared for the conference on root causes of unsustainability. What are the root causes? Ignorance. We didn't know. We didn't know what we were doing and the damage we were causing. Denial. We didn't want to know. I can tell you a lot more about climate denial. They're still around. There are people who don't want to know. Procrastination. People who are saying, no, not now. We can fix it when it comes. Let's worry about it yet. And there's a lack of will. We knew, but we didn't do. And all that adds up to a substantial spiritual problem. So I'll finish with the most telling religious symbol I know. The most telling spiritual signal I know, which is the cross of Jesus surrounded by the world, which I love very much because I happen to come from a Celtic country. Thank you very much.
Well, thank you, John, for that excellent talk to get us going. So, have we any questions? Yep.
That was very well done.
Thank you.
My name is Michael Kagan, I come from Jerusalem. And a few weeks ago I met with a scientist. I'm a scientist myself, but I met a much older gentleman than myself who works in a place called the Volcani Center for study of weather and climate and agriculture in Israel. He's originally British.
Yes.
And he would have said that this is all rubbish. I mean, he said to me that this is all rubbish. And he's been studying the weather for many, many, many years, as you two have done, and he says, no, there's actually not global warming, but global cooling. And he's been around the world measuring total light influx for many, many years and put together...
Total what flux?
Light flux, solar flux,
Yes.
and found substantial decreases in solar flux. So I'm unable to quote figures off the top of my head, but he has records from Israel and from many other countries showing that actually the average temperature of solar flux, not temperature, but solar flux, has decreased 20% over the last 50 years since records were first kept, at least in our area of the world, but he has from all over the world, and he's published papers on this. And he said he doesn't deny that there's CO2 increasing in the atmosphere, but he said he doesn't make the equation that what the cause is for solar heat, for global warming, or and he says that really all the models are wrong because nobody is taking into account global cooling. And I'm sitting listening to this gentleman who's far older and far wiser and experienced than I am, and I don't know what to tell him. I don't know what to say. I sense that he's wrong, but he says, no, I'm a scientist and I'm a skeptic and I have all the numbers and I'm right.
Well, I'm not sure exactly what he's measuring, but he's measuring solar flux.
Solar flux.
And I can imagine that measurements of the solar flux in different parts of the world and lots of parts of the world are less than they used to be because of the dust in the atmosphere.
Yeah.
So there's dust in the atmosphere keeping the sun from getting to the surface. And so that's, I could tell you more about the dust and its impact, but I'll just try and deal with the bones of the problem. If you look at the energy coming from the sun itself, that is, we've got very good measurements from space now over the last 30 years. Some people say it's changes in the sun that are causing the change in the temperature we're measuring on Earth at the moment. And that can't be true because we know the measurements of the solar energy coming in very well indeed. Some people say it's cosmic rays from the sun, and we know the cosmic rays, and on the whole they're going down. So in fact, all the measurements on the sun are negative so far as global temperature is concerned. There is no doubt at all about those temperature curves I showed you, of the increasing temperature in the atmosphere, in the Earth, at the Earth's surface, over the last 30 years. You cannot, if you run the models of what happened last century, I can show you, I don't think I've got them on this, no, I haven't got them with me just now, but people have been running models to try to reconstruct the temperature of the 20th century, using all the known natural factors, like the volcanoes which affect it, like the aerosols, the dust in the atmosphere due to increased sulfates which cause cooling, like the variations of the sun that have been known over some parts of that period. Those are the main natural variations, and also putting in the greenhouse gases. If you leave the greenhouse gases out, there is no way at all that you can get that increase in temperature over the last 30 years. You put them in, and you can reconstruct that very well. Because we know the greenhouse effect, it's been known for 200 years, it's a very good piece of physics. Your friend, I'm afraid, has just not read the scientific literature. You should look at the IPCC reports, which deal with all these issues, all the factors, in great detail, and they demonstrate, certainly to the scientific community who've created these documents, quite unequivocally, that global warming is occurring because we're putting these greenhouse gases into the atmosphere. And we know that anyway from the basic physics, really. Although we don't understand all the feedbacks as well as we should, positive and negative feedbacks, but the fact that it's warming is, I think, absolutely unequivocally due to the increase in greenhouse gases. So your friend has just not done his homework, and perhaps he doesn't want to know that it's this cause anyway.
Bob wants to say something in response to this.
Yes, I'll show those curves for the modelling tomorrow. It's my presentation second tomorrow.
Thank you, Bob.
Am I right in thinking there are a large, well, what is quoted is that there are a large number of American scientists who've signed some document recently, which is climate change denial.
Well, there's something called the Oregon List,
Yes.
which was something put out on the web by some of these people who want to get people to sign things. So they put out the sort of things that people might be likely to sign. They got something like a couple of thousand, I don't know how many thousand people they got to sign this. They said they were scientists. They were not all scientists at all. There was no check on who they all were. I was told by somebody, I don't know if it's true, that the Spice Girls had actually signed it. And it really has no credibility whatsoever. And you can't, and this sort of stuff is pushed out and it's hyped up, and they say they've got these things, and it just really doesn't ring true at all. Because you ask the climate scientists in the world what they believe, and I just told them.
Thank you. Colin, I think.
Could you comment on what is quite often said, that these are small effects which are buried in the noise of the changes which we all observe, and that they are in fact averages of averages, and therefore they can be considered as statistics, which are notoriously unreliable?
Well, the statistics, I mean, there's a lot of statistics goes into the observations and our interpretation. That doesn't mean to say they're small. In fact, they're large changes. The temperature changes I've shown you are greater, the rate of change of temperature is greater now than it's been probably for 10,000 years.
Yes, but to the ordinary person, they're small in comparison with the daily variations, and so they're unimpressed.
Oh, but these are, I've given you global averages, okay? 1 degree C in a global average is a big number. And I tried to explain that if you go from the middle of an ice age to the warm periods in between, the middle of an ice age, this part of the world would have been covered just about the southern limit of the ice.
That's a very powerful
and that's enormous. That's an enormous change we're talking about, and we're talking about the equivalent this century of half an ice age in climate change terms. That's very large indeed. So don't be misled by the seeming smallness of these numbers, because they're not small.
Thank you.
Yeah.
I don't know if you would know this, but there's been serious flooding in the United States in the Midwest.
Mm-hmm.
Would you have any reason to know whether this might be attributed to some of the climate changes you've been talking about?
You've got to be careful about attributing any given extreme event to say that is due to global warming. Because climate is a very variable thing, and has been for a long time. Climate extremes have been known for a long time, over centuries. We've had floods, we've had storms, we've had droughts, we've had all sorts of things. We haven't had heat waves like the 2003 one in Europe, so that stands out as something which is, the risk of that is 7 to 8% due to global warming, due to greenhouse gases. So you can't say that any given flood in the Midwest or any given hurricane, like Katrina, is definitely due to global warming. It's the trend in the number and the intensity of these events which is beginning to tell us that some of them are very, very likely due to global warming. And that's happening in the world at the moment. We're getting more on most of these things. But any given event, you can't say that's definitely due to global warming. That would be unfair on the statistics, which we've just been told about.
Is another, you talked about more intense hydrological cycle, I think.
Yes.
Would that include also more hurricanes, more monsoons, or whatever?
Well,
Or
certainly
typhoons,
it
I mean.
includes more floods and more droughts. So we talk of tropical cyclones, hurricanes, and then there is no evidence that the number of those will increase. We've no evidence that the number will increase. And the number is very variable actually from year to year for all sorts of reasons about the formation of hurricanes. But there is very good evidence, I think, that the average or the number of the most intense storms will increase, or the average intensity will increase. And the reason for that is because a strong driver, well, the main driver for energy, of course, of a tropical cyclone is the temperature of the ocean surface. It's the water vapour evaporating by this enormous swirling around, evaporating in large quantities into the storm that feeds it with energy. You increase the temperature of the sea, and the amount of water vapour coming into the atmosphere goes up, and hence the condensation of water vapour, which is providing the energy for the storm, goes up also. And it's quite a steep curve, is that relationship. So it's not surprising that in fact the number of intense storms is likely to increase. But for any given cyclone, there are a lot of factors which determine whether it starts, where it goes, and the amount by which it goes. So it's not a simple relationship.
Yeah.
A lot of the questions here already point towards the disparity between public understanding and the understanding of the scientific community. For the most part, the scientific community are as one on this story. But the report this week that a poll of 2,000 people in the UK revealed that 60% of them weren't yet convinced about the climate change story indicates the communication is not working all that well. You're a great communicator and have a lot of experience. Can you tell us how to do it?
Well, I've not seen that statistic, that's really a new poll, but depends what they were asked, exactly what they were asked. A very big problem, ever since 1992, when the Climate Convention was signed, has been the massive misinformation campaign, which was promulgated by the Exxon Oil Company in the United States, plus the American coal companies and some other particular interests in the United States. They put tens of millions of dollars into this misinformation campaign. They hired top lawyers to persuade people that the stuff which was being put out by the IPCC and by the scientists was not true. They tried very hard to destroy the IPCC. They tried to discredit the IPCC. They tried to discredit me personally by their efforts. They persuaded most of the members of the American Congress that they shouldn't take it seriously, because they had lawyers operating in Washington persuading people that this wasn't the case. The scientists, for their part, of course, are not very good at that sort of thing. The scientists don't go around doing that sort of thing. We're not media people. We don't hire top lawyers to get our message across. We don't spend lots of money on it. That's not by and large our business. But that has gone on for a long time. And the media have also played a part in that, because they love having the contrarians. And until very recently, whenever they asked me to talk on a media programme, they would also bring a contrarian in. And that's very difficult, because you only have a couple of minutes, and the public have to decide, do you believe Houghton or do you believe the contrarian? And some of them are very good at it. They're good at saying things. I have to be accurate and try to be absolutely truthful. They don't have to be truthful at all. They can say the first thing that comes into their head, and they do. And they have put forward absolute rubbish about the work of the IPCC, when most of them have never even seen one of our reports. So that's been a major problem. It's beginning to go away now, because people are beginning to be convinced, because of what they've seen and the floods we've experienced, and the problems around the world of droughts and floods and rising sea level and the melting ice. They're beginning to get, and Al Gore's film, they're beginning to get convinced that there's really something in it. But they still, a lot of people don't want to believe it, because they think it's going to be very negative for their lifestyle. Because another thing the misinformation campaign does is to tell people, we can't afford it. You're going to have to give up all sorts of things in order to do this, in order to cut your emissions. And therefore, we're all going to be worse off, and the American economy will collapse, that is what they were saying over there. And we're going to have to walk everywhere. We can't use cars, we can't use anything. We can't live the sort of lives we don't want to live. So people are persuaded that they shouldn't support it. Well, none of that is true. To that extent, that we will have to change from the way we think. We will have to change the way we look after other people in the world. We will have to use some of our resources to help the poor in the world. If we've got any humanity about us, we've certainly got to do that. And we will have to drive cars that don't consume so much petrol. We will have to learn to do things much more efficiently in energy. We will have to recycle more and do all the things that are very good for us to do in many ways, and which will help us to have healthier and better lives, and more sustainable lives in other ways too. There's a great deal of benefit in no regrets policies, they're called, benefit in doing things to combat climate change, which we should be doing anyway. But people are very frightened by that, especially when some people in the media tell them that life's going to be harder. So there are lots of pressures on people not to believe, and also reasons why they don't want to believe. So there's a big problem there. And I urge all of you, if you believe the story I've told you, to take it seriously and do what you can to persuade people of the science of this business, not only the science, but also the moral and spiritual implications.
Thank you. I can see we've got several questions, I think. Yeah.
My name is Yoram Zandaus. I'm a developmental pediatric neurologist from Israel. My question is, do you have any facts or figures concerning health changes due to the changes in climate?
I'm sorry,
Health
Health
changes.
changes?
Yeah.
Yeah. So, any evidence or figures to do with health change?
health change.
I'll show something tomorrow. I'll show a slide tomorrow.
Bob's going to show
Don't
something.
advertise tomorrow, okay. But I mean, health changes, we will have problems because of, we won't have enough food, or we can't grow the food we need, all that sort of thing. There is probably likely to be an increase in malaria in some parts of the world, but then we may have the means to combat malaria much better by then. So I don't make a big thing of that, because I think that that's not likely to be the big problem that some of the things I have told you about are going to come.
The back, yes.
Just following up the influential lobbyists spreading climate denial, just to let you know that I know that at least one bishop has recently received a book and a CD-ROM extensively setting out the case against climate change, accompanied by a letter. There's considerable resources still going in, sending information and resources to people arguing strongly against, where there isn't.
Yeah,
there isn't that same impetus.
They're still at it. On the whole, now they don't say. They used to say it's not happening at all. They don't say that anymore. On the whole, they say it's happening. Of course, it's happening. We all know it's happening, but it's not that bad, and we don't have to do anything now. That's the latest X online, I think.
And when the Romans were in England, there were vineyards or a long way up north, and we were just going through a natural climate cycle. That's one that I often get coming back to me at talks.
Yes. Well, there was a warm period in England during the medieval warm period, and there was a little ice age also later on when the Thames was frozen every winter. So there have been variations in the local climate in England and in Europe, but when you're talking of global averages, these things are really very small in a global average. And there are other parts of the world. The United States has hardly been warming this century, actually, compared with much of the rest of the world. So they say, oh, it's not been warming here at all. But the United States is only a small part of the whole globe, in area terms.
Yeah. I wonder if I could raise the area of the moral imperative, because the bottom line does finish up becoming a moral imperative. If you don't have that feeling, you've got to do something, you should do something, you're not going to do something. And the question is, how do we get more people to feel that they should do something? And in context, governments, and so on. And given that religion is an issue here for our course, given the course you've not spoken much about that, I want to draw you a little on why is it that the body which has the greatest number of volunteers, and voluntary people if you like, religions, and
what we would call in Christian terms churches,
Mm-hmm.
and a Bible,
Mm-hmm.
when you look at it now and in the past, by and large, have not been giving a moral imperative, a religious to spiritual dimension, which would have big influence if it were done right across the field, simply because those other community groups that are around. So why is religion so poor with a moral imperative in this area? Now I'm drawing you a little there.
No doubt we'll come back to that.
I know we'll come back to that later.
But
He won't be here, so I want to draw
As
it
you say,
back.
more, that's more. But it's a very good question, of course. The churches and other religions are the biggest NGOs in the world. If you could get those people on board, you've really got something. Let me just, I've had a certain amount to do with Christians in the United States, because if only they would change their attitudes, that's a country which is basically a Christian country, or states it's broadly a Christian country, that's doing the least in many ways to combat the issue. There are things going on there, but in terms of their administration, it is certainly a big denier of this issue. And why is that? And what's happened in the United States? Now, I've already mentioned the big, powerful oil interests and coal interests and people who really picked it up and gone against it. As far as Christians over there are concerned, I've had a certain amount to do with what you might call the people, the right-wing end of the Christian church, the evangelical end of the Christian church, who have not felt at all for many years that the environment is something they need to care about. In fact, rather the opposite, because they are opposed to some of the sort of people who promote the environment. They think they're new agey sort of people. They haven't got the sort of agendas or spiritual agendas as the Christians have. They also feel they're against progress, they're against business, they're against the sort of lifestyle that they believe is an appropriate Christian lifestyle, the work ethic and all those things. They don't think that they are really supporting that sort of thing. And they believe that God has given us the earth to use and for our benefit. And they therefore are not, and they also have not had a strong doctrine of creation. Although they believe in God as creator, and that is undoubtedly the case, they also believe that in the end, God will give up on creation to a large degree, and on the material creation, and that there is a new creation and a spiritual world out there which will all go and enjoy in due course, and so I worry about the earth we've got down here. And there's been a fair amount of that around too. Now, I've been involved in meetings and in study groups and in some very senior people in that body, many of whom have now turned around. And the National Association of Evangelicals, which has 50,000 churches in its remit and 25% of the American population, have published statements now to say that creation is very important and that climate change is a big issue that Christians should really be taken seriously. So that's really beginning to change over there. Not everybody has changed. There are some very powerful bodies who are still playing the role of deniers. But a great deal has happened to change that. And it's something Christians are beginning to turn around in this country and elsewhere also. They're beginning to believe that creation is a very important part of our agenda as Christians. God couldn't have given us a stronger message than sending Jesus, his son, into the world to be a human being. Became part of creation. And God's not going to give up on creation. God's committed to creation forever. It will be one day, we believe it will be a new creation, transformed creation in some ways we don't understand. Because we're promised that as a result of the resurrection of Jesus, who had a new body, he belonged to that new creation. but it also has a very strong link with the present creation. So there's continuity and discontinuity between this creation and the new creation. So there is a real hope for the future, because God is committed to his creation, which was a phrase I used on the slide. And I believe that very strongly. And as a result of that, probably people say, well, why worry if God's looking after it? Why do we have to look after it too? The answer to that is because he told us to. Our instructions right at the beginning of the Bible, Genesis 2, was to be put in a garden and to care for the garden and to serve the garden and to work the garden, because that was our task, God-given task as human beings, to look after the earth and to care for it in ways which are wonderful to know and which we don't do very well. In fact, we're doing it very badly at the moment in many ways. Nevertheless, that's our God-given task, and it's a thread that runs through the whole of Scripture, through the whole of the Bible, for us to do that. And therefore we should be looking at, and now there's 60 billion of us on the world, we've really got to take that caring very seriously and make sure that all the things that we do are positive towards the health of the creation that God has so wonderfully provided for us. And when it comes to the sort of changes I'm talking about in climate change, we've got to do all we can to make sure those changes don't really damage the poor in the world in the way they're bound to do to some extent, or damage the rest of creation, other ecosystems, losing species and all that, which they're bound to do to some extent. We've got to try and reduce that to the minimum possible. That's an enormous challenge for us, which we should be taking up, and we should be spreading that news to all the people around us.
That's tremendous. I think we probably need to be drawing this session to a close. John's opened up some very important issues for us, and some of these will go on being explored over the weekend, so there'll be more opportunities for that. I think just before we thank John again, the mention of Al Gore brought to my mind, of course, one very important fact I didn't mention earlier on, that John shared the Nobel Prize with Al Gore.